was with the angle addition postulate, I believe. Remember, what we always want to do is we want to draw a parallel between what we did last section with segments and what we're doing this section with angles. So real quick, we talked about the segment addition postulate. Remember what that said? All that said was if we have some segment where, let's say, point B is between points A and C, right? Then what's the relationship between those distances or those lengths of those segments? We've got the, oh, there you go, good. Okay, so AB, which means the distance from A to B or the length of segment AB, plus the length of segment BC must equal what?
AC.
The length of segment AC. Okay, very simple. So that's what we talked about last time. Now, corresponding to that, we've got the angle addition postulate, which just says that if point P is somewhere in the interior of this big angle, right? So here's point P. It's in the interior of angle. Remember, this was wrong, wasn't it? So this should have been, what should that have been? Angle QRS. I gotta fix that. Then, if we define another angle, we draw another ray from R through P. So now we define these two smaller angles, right? Then doesn't it make sense that the measure of angle QRP plus the measure of angle PRS would have to equal the measure of the big angle, right? Now that's only going to work if they share one side though. In other words, if the angles are adjacent. Adjacent's a big word in math. All adjacent means is what? Next to. That's it, right? So if the two angles are next to each other and share a side, then that's always going to be true. So we can use that fact to do problems like this, okay? These are the kinds of problems I'm going to give you all year. These are great problems because they ask you to do kind of you have to think in two ways. You have to use a geometry relationship to set up an algebra equation. Then you can kind of just shift into algebra mode and forget about geometry for a second, do the algebra, get an answer to the algebra problem, and then take that answer and use it to kind of go back into geometry mode and answer the question, right? Interpret the answer. So what can we set up here then? If we know that the measure of, I'm going to write these in. If we know that the measure of angle QRP, so that's this bottom one, right? If that's equal to 5x degrees, and the measure of angle PRS, so that's kind of the top angle, is 2x degrees, and we know that the whole thing has a measure of 84 degrees, can I set up an equation there? Yeah, what's my equation going to be? Oh, okay, does that make sense? So I know that the measure of the left angle plus the measure of the right angle must equal the total measure of the big angle by the angle addition postulate, right? So we get that, right? Now that's easy to solve, but now we can just focus on the algebra for a second. What do I do to solve that? Okay, combine like terms. 5x and 2x is 7x, divide by 7, and what do I get, 12? So x is 12. Now, is that the answer to the problem? Well, probably not. The kind of questions I'm gonna ask you on the review assignment at the end of the unit are gonna be, yeah, I might ask you for x, but I'm also gonna ask you for the values of the angles, the measures of the angles. So how would I find the measures of those two angles?
5 times 12 and 2 times 12.
Good. Okay, I've got to take this value of x and plug it back into those expressions, right, that are going to give me the size of the angle. So I'm going to get 60. 5 times 12 is 60, and 2 times 12 is 24. Okay, make sense? That's it. Okay. Real quick, very quick review. Types of angles. What is an acute angle? Less than 90. Good. Okay, what's a right angle? That's what it might look like, an acute angle. What's a right angle?
90.
Exactly 90. Good. How do we represent that? What's our symbol? Okay, good. Little box in the corner. Okay, good. What's an obtuse angle? Okay, larger than 90 and less than 180. Good. Between 90 and 180. And then what's a straight angle?
180.
That's the one that's 180. Good, so it just looked like that. Okay? Adjacent angles are just next to each other. We already mentioned that. So angles 1 and 2 are adjacent because they share the same vertex and they share a side. So there's an example. Okay, real quick, right here. Can somebody tell me, now there's lots of ways to name these angles. Name an acute angle. Somebody. So go ahead, Cass. What is it?
What?
What is it? An acute angle.
SPT.
SBT works. Yeah. What's another name for angle SBT? Angle 3. Alec, what's another one? What's that? Give me another. Okay, we named this one twice. Give me another acute angle. TB. Sure, TBS. Another way to say it. There you go. Okay, what's a different acute angle? Yes. TBC. Yeah, good. Makes sense. So this one is also acute, and there's a bunch of different names for that one. What is a? There's some examples. What's an obtuse angle? Yes, ma'am. ABT. Perfect. Okay, ABT. A to B to T is obtuse. What is a right angle? SBA, angle 1. What's another one? SBC. Yeah, that would also work over there, wouldn't it? Okay, good. How about a straight angle?